Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and joining me again is Hanan Alyami, who is a faculty member with a joint appointment in the Department of Teacher Education and the Department of Mathematical Sciences, having a foot in both worlds there, Hanan, from Purdue University Fort Wayne. So, Hanan, thanks so much for coming back on the podcast.
Thank you for inviting me again, Sam.
Yeah, and with Hanan, it means we get to talk about radians and some geometry angle concepts, and it's always fun. I enjoy digging into some of the content. And you have a new article that has come out in Research in Mathematics Education, and this is called Defining Radian, Provoked Concept Definitions of Radian Angle Measure. And in the previous episode, you talked about radians and you were looking at representations, but now you're bringing in some prospective teachers' concept images, concept definitions, and the way that they're thinking about radians. So you're bringing some new dynamics into this research. But before we get too far into it, let's just back up, make sure everybody's on the same page. We're talking about angles, we've got degrees, we've got radians. Make sure that we're sort of on the same page with those. And then remind us of what it was that motivated you to really think about researching the understanding of radian measure.
Well, thank you again, Sam, for inviting me. Before I delve into the difference between degrees and radians, I want to touch on a different distinction when it comes to angle and angle measure in general, which in this article I describe as qualitative and quantitative views of angle. So the qualitative view of angle focuses on the geometric aspects of an angle, like thinking of an angle as a vertex or as a corner. And then the quantitative view of angle focuses on measurable aspects of angles, such as the amount of space between the rays or the amount of turn from one ray to the next around the vertex. So if we think about angle measure, which is conventionally relating the angle's subtended arc to the full rotation angle as a benchmark, the difference between degrees and radian is in the benchmark that constitutes this full rotation. Specifically in degrees, that arc subtending the angle is quantified as a fractional amount relative to 360 total sections that form the circle's circumference. But in radians, that is a fraction of 2 pi. That is the benchmark for a full rotation angle. So the reason why I bring up the qualitative and quantitative views of angle is because through my research, I wondered if the challenge learners might have with understanding this conventional approach to angle measure might be a reflection of the complexity of the angle concept itself, and maybe an impact of the qualitative and quantitative views of angle.
Yeah, and it seems like exploring this space is a way to really get at the deeper conceptual understanding of angles and radian, and looking at radian representations, thinking about radian, talking about it is, to me, an avenue to just reveal what does the person really think angles are in their sort of essence or in their complex essence. And so radians sort of is a way to get at that. Would that be fair in how you approach it too? Are you approaching like angle as the deeper concept underneath and radian as a way to get into that? Or are you also interested in like radians themselves as a way that you love to think about angles?
Well, that's a good question. I think I started my research with radian because of my interest in radian as a concept itself. But the more I dig deeper into it, I got into this idea of angle as a geometric object itself, and radian being a unit for measuring angles. So understanding this general concept of angle and its measure with radian as the unit for that exploration.
And then also in your article, you talk too about how the higher levels of mathematics really rely on radians quite a bit. And it's sort of a disconnect because in school mathematics, middle schools, high schools, they're very much more about degrees. And I would say the general public is also much more, at least in the United States, is more about degrees. And so there's kind of this disconnect as well, where it's like, oh, going up into mathematics, into the mathematical realms, radian is the one that brings this much more elegance to the way that we work with angles.
Well, and again, it goes back to this idea of the similarities between them. If degrees are understood or conceptualized with the conventional approach in mind, that thinking can extend to radian, and it won't be a challenge in understanding that. I think the challenge becomes thinking about degrees in a qualitative way makes it harder to extend that thinking into radian quantitatively.
Now, in this article in Research in Mathematics Education, you looked again at the textbook representations and the diagrams that are used around radians. So, first of all, help us set the stage with what you did see in the textbooks with those representations.
Yeah, well, this gets into the origin of this research, which in the previous article that was featured in episode 2001 of the Math Ed podcast, I talked about exploring textbook representations of radian from the perspective of qualitative and quantitative views of angle. And at the time, I found that textbook representations of radian are predominantly qualitative, meaning out of the 20 diagrams that I looked at from 8 different textbooks, I only found 2 diagrams presenting radian with a quantitative focus. The rest were either emphasizing representations of one radian as a special case, and the rest were qualitative in focus, which means that it was challenging to discern from the diagram how radian measure is quantified. So the extension of that work in this article is in the way that I designed and organized the task, because I wanted to explore the concept definitions that would be provoked by these different textbook representations, and if the type of representation has an impact on how someone would formulate a definition of radian. So the task included 6 different diagrams of radian. 2 of the diagrams or the representations were qualitative, again, meaning that it was hard to discern how radian is quantified from looking at the diagram. 2 of them were quantitative, so the diagram presented a quantification process that relates to the conventional approach for angle measure. And what at the time I called a mixture of both qualitative and quantitative. And those were diagrams that had some quantification elements, but were limited to quantifying 1 radian. And actually, after this study, I started describing them as diagrams that emphasize equivalence because of the findings from the study.
Nice. With those laid out, though, then you had prospective teachers that were looking at them, reacting to them, and then you were sort of analyzing how they interpreted those representations of radians and looking at their concept definition, concept image. But first of all, just set the stage for us in terms of what data you had and how you analyzed that data from the prospective teachers.
Yeah, so I interviewed, using that task, I designed a semi-structure interview, and I interviewed math prospective teachers one at a time. And what I did in gathering the data was presenting them the diagrams one at a time. I hand each diagram in a specific order, and I would ask them, so how would you describe radian angle measure through this diagram? And I categorized their answers based on the diagram itself, but then based on the quantification elements that could be found in how they were describing radian from looking at the diagram.
All right, excellent. So let's just dig right into what you found there. What were some of the highlights or the main themes that came out of your analysis of those prospective teachers' concept definitions and how they were interpreting and reacting to those radian representations?
The main thing I found is that math prospective teachers can describe radian quantitatively. There were some definitions that were not complete, meaning they mention either the arc length or the radius or a relationship between those. So different components of radian angle measure without clarifying the relationship between those components quantitatively. And this happened when the diagrams were either qualitative in nature or when the diagram emphasized the presentation of 1 radian. However, the prospective teachers' quantitative definitions of radian included describing equivalence, so attending to that 1 radian representation by describing it as an equivalent or emphasizing the equivalence between the arc length and the radius being equal, or through the process of iteration by adding up parts to form a whole, like saying that if you stack up 1 radian, you will have 6 and approximately a quarter, making up a full rotation, which hints to the whole rotation being 2 pi. Some of the prospective teachers' definitions included attention to proportionality, like saying that the arc length is proportional to the circle containing the arc. So if you have multiple circles, the arc length will be proportional to the circumference containing the arc. But the most important of these descriptions was when they were partitioning. So the prospective teachers described breaking the whole rotation angle of 2 pi into what Henry called easy fractions of pi. And actually, Henry's partitioning was of the semicircle in this case. And I found this as the most important because when partitioning the whole rotation of 2 pi radians, unless 2 pi is conceptualized in relation to a unit, this partitioning approach might be an arithmetic operation of successive divisions. And so it led me to extend this work because I wanted to also explore the concept images of radian to understand the nature of how the prospective teachers were viewing pi in relation to radian angle measure, and if pi is conceived qualitatively or quantitatively in that case.
Yeah, great. A lot of good stuff there. I do feel bad at being an audio format because in the manuscript you have pictures of what the students are looking at and then how they're kind of interpreting it. So I do encourage listeners to grab this article from Research in Mathematics Education and pull up some nice diagrams of what they're talking about, and I think that will help put an image to some of the things you're talking about. I'm also just curious here, by the way, Hanan, and what you were seeing, whether these interpretations and the ways that the prospective teachers were thinking about it, did it kind of come cumulatively as they were seeing multiple representations, or were there certain representations that were kind of a key moment where, it sparked something in them? Or this is maybe not the exact focus of your analysis, but I think maybe it's something that you can comment on from having done the interviews and looked at that.
Yeah, this is a very good question. And a big limitation of this article is the presentation of the diagrams one at a time in that specific order, because yes, you will be reflecting on what you have gathered from the diagrams that you were seeing before. So even if I was handing the diagrams one at a time, there is an influence of the diagrams that you have seen before them that was outside of the scope of the study, as I wrote. But I do, for example, I would say that when thinking about diagrams 4 and 6, some of the participants were talking about how diagram 6 completes the circle, which is an extension to the not completed circle in diagram 4.
Mm-hmm.
But it's interesting because diagram 4 helped them think quantitatively about this iteration process, because even though the circle was not complete, they understood that in order to complete it, if you are completing the full rotation, you're thinking about 2 pi, and you only have 6 arcs that are the length of the radius, meaning to complete it, you need to go to 2 pi.
Mm-hmm.
And I appreciate this question because I always wanted to see how would that extend to their thinking of diagram 6, because would they have thought about partitioning in diagram 6 if they haven't seen diagram 4 before that? And I can't know unless I have done that specific study where the diagrams are presented in a random order every time.
To me, it's just also interesting to see up close this process of the concept definition and the concept image that's somewhat pre-existed your interview, but then during the interview, it was probably taking sharper focus, and it was maybe getting kind of filled out as they were looking at it, thinking about it, expressing it to you. And it's interesting to see up close this process of a person, a learner, a pre-service teacher, whoever it is,
Mm-hmm.
integrating multiple things that they're looking at and starting to put the pieces together.
Right.
And even though that might not have been the exact focus of this study to see how the pieces are put together or how they are interlocked, to me, it's still interesting to take this close look at how are they understanding it? How are they expressing radian? What kind of mood are they having for the radian? What kind of form is the radian taking when they express it? And then to put different pieces into place, to be like, well, here's number 4, here's number 5, here's number 6, and it's all adding to this complex web
Mm-hmm.
that spins around the concept definition or the concept image.
Right. And especially with diagram 6, which I intentionally made that the last diagram they see because I know that they're familiar with it.
Mm.
So I don't know if the type of complex thinking that was provoked from diagram 6 would have been as complex if it was one of the first that they saw.
Mm. Now, you're doing some additional analysis around this, as you can tell, you've been thinking about this for some several years, but the article we've been talking about is in Research in Mathematics Education, but you also have a new article, congratulations, by the way, in Mathematical Thinking and Learning. That's
Mhm.
amazing. But that one, you sort of are in the same space, but I wonder if you could talk a little bit about how that article adds to this conversation about radians and about how the prospective teachers are thinking about radians.
So the main thing about the mathematical thinking and learning article is extending this previous understanding of prospective teachers' concept definitions in their use of pi when it comes to radian. Basically, qualitative representations resulted in a fixed conceptualization of pi when it comes to measuring angles in radian, which is why I titled that article Radian Pi, because there is a strong concept image of pi when people think about radian, but it manifests differently depending on the context. And I think that was one of the main findings of that second article. So, just to give you an example, there's the conceptualization of pi in relation to degrees by thinking about pi as 180 degrees, but there's also the connection between the quantitative value of pi as approximately 3.14 when looking at diagram 4, for example. So a specific example is what Elaine said when describing diagram 4, saying that it will show the circle as having a little bit more than 6 radians. She specifically said that would make sense because the circle has 2 pi radians, which is approximately 6.2. So what I tried to convey in that second article is this differences in how pi is conceptualized in relation to radian, that it's not just the fixed symbolic representation, but it also what that symbolic representation relates to.
Yeah, wonderful. Well, it's definitely great to hear about you continuing this work. And if listeners are interested in angle measure, radians, degrees, or looking at some of your tasks that you've devised, or the careful way that you've looked at representations of radians and things, definitely I think you're the person to come to for all those things. And it's great to see you continuing to work on it.
Yeah, and I'm continuing to work on it and extending it since I am working with elementary pre-service teachers now. I'm also curious about how that relates to degree measure understanding.
Hmm.
So thinking about the units of measure in general, but also the units for measuring angles
Right.
specifically.
Yeah. I'm not an expert in this area, but I immediately just imagine, with degree measure that there might be a qualitative sense where there's like a right angle that's 90 degrees, and 90 degrees is almost just a name for that shape of a right angle. 45 degrees probably is another thing. But then you could just have this qualitative judgments of like, oh, it's similar to a 45-degree angle, or it's about a 90-degree angle, or a little bit less, or a little bit more, or something,
Hmm.
versus a quantitative sense where this degree can be along the whole continuum of anywhere between 0 and 360, and you can start to do operations with those and thinking about it more quantitatively as this measure. Another, yeah, interesting realm to explore, or others might have as well, but to me it's just fun to think about.
And you bring up an interesting point because while I talked about how I described angles in this article that focused on the concept definition using qualitative and quantitative, that idea evolved in the mathematical thinking and learning article because it always sounded like I am pitting qualitative and quantitative views of angle against each other. And
Mm,
I am not. You actually bring an interesting point when you talked about the qualitative view of 90 degree as having this shape. Well, you can include quantitative elements of it
mm,
because you know that it's 90 degrees, then to make a 45 degrees, then you have to bisect that
hmm,
fixed 90-degree angle that you understand qualitatively by thinking about the process of partitioning.
mm.
And so you need both. And that's why in the second article, that idea of qualitative and quantitative evolved in how I described it to convey that they're not dichotomy.
Hmm. And we're not trying to move people away from one to the other. It's actually just about respecting both of them as part of the concept definition.
And building on what the learner spontaneously would gravitate to. if it's easy for you to bring to your conception what a 90-degree looks like, then there's a lot of quantitative aspects that you can apply to it to think about a 10-degree angle by breaking it into 10 sections, or
Mm.
45 degrees by breaking it into 2 sections, or
But also putting together three 90 degrees and starting to iterate them like that. What does that get? Yeah.
perfect. Yes. So it is, they're not against each other. They actually work together, and we need both as opposed to trying to move from one to the other. So thank you for allowing me the opportunity to talk about that.
Yeah, that's great. Thanks. Well, I always like to do kind of a personal fun question at the end. So, Hanan, I would want to ask you, is there maybe something that people listening might not know about you? Is there kind of a fun fact in your history or something that might be fun to share?
Yeah, I shared this with people in my close circle, so I would love to share it with the general math ed podcast listeners, which is a fun fact about me is that I learned English watching TV, and I always joke that I learned English watching Seinfeld, which is why I understand American humor.
Wow, yeah, at least a certain category of it for sure.
Right.
I noticed that you had a pseudonym from this article that was Elaine. You mentioned her earlier.
Right.
Is that a coincidence or is that actually some fondness for the Seinfeld
It
characters?
is some fondness for the Seinfeld characters, and I wanted to name every pseudonym by different Seinfeld characters, but I also allowed some of my participants to choose their own pseudonyms, so
Uh,
that kind of what broke the cycle.
Newman. Okay.
Yes, exactly.
No, but I think watching TV is not the worst way to learn English, probably. Have you felt it has served you pretty well?
I think it helped form a little bit of preconceived notions, which thinking about coming to the States and interacting with Americans, I'm thankful that not everyone around me acts like Seinfeld characters.
Well, Hanan, thanks again for coming on the podcast, and it was great talking to you.
Thank you for having me.